Welcome along, Explorer. It's been a long week down here on planet Earth, so how do you fancy quickly exploring the universe with me? My name's Dan. Let's get to a brand new Fun Kids Science Weekly. This week in the show that searches out all the secrets through the solar system, we'll find out what would happen if Earth got bored with life here on the Milky Way galaxy and decided to head off somewhere by itself.
What's the most likely way it would happen? It would be a collision with another galaxy. So our nearest galaxy, apart from the Milky Way, is Andromeda. Andromeda is about 2.5 million light years away from us.
Also, we'll dig into the secrets of the past for our Battle of the Sciences, learning about archaeology.
It's important that we scientists sometimes admit that we don't know, and there are things that we don't know. So we know a lot. We know a lot of what they did, a lot of how they behaved, a lot of what they ate, how they related to each other. But there are lots of things that we don't know.
And our Dangerous Dan takes us on a hunt to the bottom of the world. It's all on the way in a brand new Fun Kids Science Weekly. And let's start with your science in the news then. A zoo in the UK has welcomed 2 new baby reindeers to their herd. One mum, Sunflower, gave birth to a boy. Another, Jasmine, had a girl. Dudley Zoo and Castle are now welcoming the creatures in. Now, they're not endangered, but these reindeer are listed as vulnerable, and they're talented too. Check this, they can run at 75 kilometres an hour, and they're the only mammals in the world that we know of that can see ultraviolet light, which is a different kind of light that you and I can see. And experts think it helps them see better in the snowy world where they normally live. So good luck to them too. Also, in animal news, wild chimpanzees give first aid to each other. That's what experts have seen in a long-term study in Uganda. Scientists have spotted apes recognising pain in others and applying treatment. Now, this is, news to us, and it shows a different side to the creatures. And every time I learn about chimps and other animals like that, I'm constantly amazed at how similar they are to us. So it's not a huge surprise that they take care of each other, just like us humans, eh? And in our final story this week, the first samples of moon dust brought back to Earth in nearly 50 years have arrived in the UK on loan from China. We can find out more from the only scientist in the UK to have been loaned this extremely rare material. He went over to go and get them. Professor Mahesh Anand from the Open University joins us. Mahesh, thank you for being there. What did you do to get this extremely rare loan?
Well, it's a pleasure to be with you, Dan. I'm a lunar scientist, which means that I do research about the moon, and in this case I actually work on the lunar samples or samples from the moon that were brought back by the Apollo astronauts. I also work on moon rocks that arrive on Earth as lunar meteorites. So I have been actually doing research on these type of samples for over 20 years, and so I guess I have what they call a track record in this field, and therefore I'm considered an expert in this area, and probably that was the main reason why I was selected.
So what is the moon dust in? How much have we got of it? Talk us through the actual specimen.
Yeah, so I have received 3 separate allocations of the moon dust that China's Chang'e 5 mission brought back in December 2020. Now, it might not sound much, but these moon dust, as you said right at the start, these are much more precious than anything that we can think of here on Earth. And gold is just one such thing we compare things against. But honestly speaking, this is there is no comparison. I mean, this is really precious and priceless material. I have received about 20 milligrams of each sample, and so I have 3 of those samples with which I will conduct my research and try to find out everything I can about the moon.
Well, I've read that it needs to be completely free of any contamination with things from here on Earth. So that would mean that you can't kind of open it and waft the moon dust around. How are you doing experiments?
That's absolutely correct. So in this case, Moon is the only other planetary body other than the Earth where humans have actually walked and have collected samples. And once we go elsewhere, we want to make sure that we keep the samples in as pristine condition as possible so that we can learn about that place which we have just visited. In this case, it is the moon. So before I start my experiment, these samples need to be kept in a very clean condition without coming into contact with the air. Otherwise, it will contaminate some of those samples. So it's a quite laborious and painstaking and complex process to take these samples out of the vials in which they are currently stored and then take them into instruments with which we will do the analysis. So there is a whole procedure that would take, maybe a whole day to get just the samples out from the vials into our instruments for the analysis.
What are you hoping to discover with your analysis?
Well, there are two big questions that I'm interested in addressing using these samples. One is, how did the moon come about? This has been a long-standing debate. How did our moon form? And your listeners might have heard about something called a giant impact, where a planet the size of Mars thought to have actually collided with the Earth, and the material that came out of that collision formed the moon. If that is the case, then there are chemical signatures that should be preserved in the moon and that tell us that that was the case. Now, scientists haven't been able to settle that debate, and I hope that I will contribute to settling that debate to some extent. Second big question that I'm interested in: where did we come about? How did we come about? How did life actually take hold? Everybody seemed to be, questioning our place in the universe or trying to understand where life might have come from. Now, moon might not be the natural or the obvious place for most people to think about that, you can address that question by going to the moon. But actually you can, because the moon has been in Earth's backyard, so to speak. It's very close to the Earth. Your listeners can actually see the moon. Only day before yesterday, or it was the full moon, bright in the sky, at least in the UK night, we could see the bright moon. They can relate to the moon. That same moon has recorded almost every geological activity that has been shaping the Earth. And one of those things relates to the arrival, presumably, of life-forming elements that scientists are interested in learning about. So if the Earth received that material, the moon wasn't far off, so it would have also received or seen the same material. Some of that record is preserved in those precious moon dust that we are trying to actually analyze and unravel that mystery.
Now, Mahesh, the last time I went on a holiday on an airplane, it was a bit of a faff with my luggage, making sure it went to the right place and that nothing was too damaged. Now, you've got moon dust, which you say is more precious than gold dust. How on earth did you actually get it back to the UK?
So, the beauty is in simplicity. So as you just said, when you were traveling, you were worried about luggage that was probably in hold, right? But I'm sure that you had your mobile phone in your pocket next to you and you weren't worried about losing that because it was on you. And just like that, when I was carrying the moon dust, it was with me in my hand luggage, with me all the time, because it is as precious, if not more, than my own life. So I carried it in my custody all the way from China to the UK. That was the easiest and the simplest way.
Let me ask you, Mahesh, how many times did you check to make sure you still had it every time you went through the airport?
Well, yes, of course, every time you take your baggage from security one side to the other, you want to make sure that the bag is still there, that's all. But, as I said, because for me, I know what was the importance of that baggage was. For anybody else, it was simply an ordinary baggage. So from that point of view, I was simply an ordinary passenger with something extraordinary in my bag. In this case, something that could turn out to be an aid in discovering something big about the moon and perhaps even the Earth itself.
It's been a real joy to find out all of these secrets. Professor Mahesh Anand, thank you for joining us.
Thank you.
Let's get to your questions then. If you have anything sciencey that you want answered on this podcast, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. That way, you can star on the show and I'll get a genius expert to sort it out for you. First up, a message from Kai. Thank you for listening, Kai, and for getting in touch. You want to see more dangerous Dans? Well, I love them too, Kai. But it does take me a little while to research and do all the digging for all the wondrous creatures or elements or planets across the universe. So we'll have to stick for one a week now, if that's all right, so I can really bring you the good stuff. But thank you for getting in touch. Here's another message from Etta. This is good, Etta, who wants to know, why do some popcorn kernels not pop? There are always a few, aren't there? You put your bag in the microwave normally, it spins around for a few minutes, makes that ooh whirring sound, and the little kernels pop. But there are always some that are a little left over that don't. They're stubbornly tough. They're just waiting to crack your teeth when you don't notice. Well, it turns out that for a kernel to pop, things need to be just right. Each one needs about 14% moisture inside. It's the water in it that needs to become so hot that it turns into steam, and that pops the kernel. The shell on the outside needs to be strong and intact. If it's cracked, the steam will escape too early. It can't build up enough pressure to burst. And if the heat in the microwave isn't spread around the bag and the kernels evenly, maybe they won't get hot enough to turn into steam. So that's why it's all to do with getting that kernel just right. It's solid enough so the water inside turns into steam, and then there becomes so much of it that it simply has to pop. Etta, thank you very much for the question. Let's get on another one then. This is from Sebastian. What do you have for us, Sebastian?
I am Sebastian, and my question is, will the Earth ever move out of the Milky Way galaxy?
Well, thank you very much for your question, Sebastian. Will Earth ever leave the Milky Way galaxy? Not only a brilliant question, but it's also got me a bit worried now if our planet just decides to go for a holiday to fling itself off across some strange nebula through the universe. Let's find out more, shall we, with Tom-Joshi Cale, an astrophysicist from the University of Exeter. Tom, thank you for joining us. So, will Earth ever leave the Milky Way galaxy?
Yeah, it's a really interesting question. So I think the biggest thing to understand in answer of this question is how would that happen? If Earth was to leave the Milky Way, what kind of things could make that happen? And there's kind of two main ways that this could happen. Either the solar system itself, so the sun and all of the planets around it, including Earth, the whole system is ejected from the Milky Way, or the Earth itself is ejected out of the solar system and the Milky Way. Of those two, to be totally honest, I don't think either of them are super likely, but the most likely of the two is the whole solar system is ejected from the Milky Way with the sun as well. And the most likely way that would happen is through a very near collision with another object. So maybe another star comes through our solar system and kind of whips the sun itself out of its current orbit and ejects it out of the solar system. For that to happen, we'd need to come quite close to another star. It would need to be really quite massive to have a lot of stuff in it so that it can push our star enough to get it out of the Milky Way. So that, I think, is also not super likely. If I had to say what's the most likely way it would happen, it would be a collision with another galaxy. So our nearest galaxy, apart from the Milky Way, is Andromeda. Andromeda is about 2.5 million light years away from us, so it's pretty far away, but it is coming towards us at about 110 kilometers a second, which sounds quick, but when you're talking about 2.5 million light years, it's not quite so quick. Astronomers like me, we predict that Andromeda and the Milky Way are going to collide in about 4.5 billion years. That's quite a long time, and also that collision, it's not going to be loads of stars smashing into each other, big explosions, lots of planets crashing together. What's mostly going to happen is that everything will miss and pretty much everything just moves past each other. But there'll be much more stars in our local area during that collision. And so if there was a time where we'd come close enough to another object to eject us out of the galaxy, it would be as part of that collision in about 4.5 billion years. So it's quite a long time to wait. I think we'd all be okay. And the odds are, unfortunately, I suppose, if you are interested in seeing what life was like outside of the galaxy, that we'd have to wait for that collision, and we still probably wouldn't get ejected out.
Well, I think that our planet is about 4.5 billion years old as it is. Is that right? Or so we're kind of like halfway through what could be the planet's life. I think that's pretty mind-blowing. So what's keeping us in place? Earth, we are orbiting the sun in our solar system. Is our solar system then drawn in by the gravity and orbiting a much bigger star too?
So, yeah, it's similar to that. So you're right about the Earth's age, that about 4.5 billion years. And actually, the sun is expected to survive for another 5 billion years before it goes supernova. So we'd have to get that collision in just before our sun went supernova. But to keep the Earth in place, Earth is orbiting around the sun, and then the sun is orbiting around the center of the Milky Way galaxy. So in the middle of the Milky Way galaxy, there's a supermassive black hole called Sagittarius A star. And it's huge, and it sits there in the middle of the Milky Way, and it's because it's so massive, it has this really strong gravitational pull that everything else in the Milky Way and the whole galaxy is orbiting around, and that's what's controlling where our sun goes. We're in an orbit around Sagittarius A star, and then the Earth is in an orbit around the sun. So we're also orbiting around that black hole, but because we orbit the sun.
Wow. Yeah, so it's mind-blowing. I mean, I talk about science and space all the time. You're an astrophysicist, but it's still mind-blowing. It's been really good to chat to you, Dr. Tom-Joshi Cale. So, Sebastian, will Earth ever leave the Milky Way? We don't think so, but if you want to find out, then you'll have to live to be 4.5 billion years old. Good luck with that. Tom, thank you so much for joining us.
Thank you very much for having me.
If you have any questions that you'd love answered on the show, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. So this week I've been putting the final touches, dotting the I's, crossing the T's, making sure the experiments are just the right amount of explosive for our Fun Kids Science Weekly live tour. Are you coming? All summer through the UK, I am playing theatres around the country, bringing science to you. Bringing the universe's greatest podcast to you on stage. And I won't be alone. We'll have genius experts. They'll be coming on, having a chat, uncovering the universe with us. We will have maybe some deadly beasts. Also, I have seen photographic evidence that there will be a meteorite with me. It's on its way. From space, through a few post offices, to me, to you. You can come along, you can learn the secrets of that meteorite. So if you'd like to see the Fun Kids Science Weekly live on stage, make sure you come along to our tour this summer. We've got loads of dates booked in, hopefully more to come. Find out where and when I am playing near you with some grown-ups. Get to funkidslive.com/tour. Now, for this week's Dangerous Dan, where we explore the entire universe, we search out the really weird, odd, strange, unique, and often deadly things. We are headed to the very bottom of the ocean, to the Antarctic, where it's so cold that one animal has learnt to thrive in the freeze. The leopard seal is the second largest species of seal in the Antarctic, can grow to 3.5 meters long. The females are 1.5 times bigger than the males. They can weigh up to 0.5 ton. They've got that sleek grey body that you think about with seals. They've got a white belly, which helps them blend in for creatures looking up, mixes with the light. Their grey back helps them merge with the ocean for any animal looking from above. They blend right in, they bob around. It's one of the top predators down there, known for its massive jaws. They slam down on prey. Their front teeth are sharp and spiky like a carnivore's, but some of their teeth can lock together, which helps them sieve small fish from the water. They're especially adapted to tear flesh and rip apart all sizes of creature. They're fast, they're agile in the water, they're aggressive and powerful. They're not hanging around, they go on the hunt. The leopard seal feasts on fish, birds, and even penguins. But notice, I said They are one of the top predators down there. They're not the top one because they are prey themselves to just one animal, the apex predator, the killer whale, the orca. But still, coming second in the Battle of the Ocean is a pretty big deal, and it means the leopard seal goes straight onto our dangerous Dan list. For this week's Battle of the Sciences, where we try so hard to discover once and for all the greatest science in the history of the universe, we are looking into history and how we find out more about it, like digging deep underground and what that shows us and how we move on with it. We're talking archaeology today with Alfredo Cortel-Nicolau from the Max Planck Institute for Evolutionary Anthropology. Alfredo, thank you for being there. You have 1 minute to tell us why archaeology is the greatest science of them all. That minute starts in 3, 2, 1, go!
Imagine that you are in an archaeological site and you are there digging, and then at some point you find an arrowhead, and that arrowhead is 10,000 years old. And then you could be the first person seeing that arrowhead in 10,000 years. And from that, you could start learning, you could start questioning and thinking, how was people doing things in the past? So essentially, by finding all these things, you can try to understand what we are, what we have been, and what we have been doing throughout all of these years, from the early stages of humans until the present. And I think that's pretty cool. And on top of that, we do have field work, which basically spends being in a camp for 2-3 weeks, playing with the earth and in the mountain with your friends. So what could go wrong about it? That's pretty cool.
There we go, archaeology. Well, Alfredo, thank you so much for that. So what are the skills involved in being an archaeologist? So you've got someone out in the field. You might be out there digging, as you say, looking for this arrowhead. When you find it, what's the science involved in finding how old it is, seeing who might have used it back in the day?
So that's another cool thing about archaeology, because actually you're looking at everything that humans do, just that in the past. So then depending on what you're looking for, you need to do one thing or another. And we have different techniques. We can know through different chemical processes, we can know how old a site is based on the remains of bones, the remains of seeds, and all these kinds of things. We can know, for example, what people ate based on other different techniques. And we can do like more advanced, say, we can test our ideas in more advanced methods. Like, for example, we can design video games, kind of video games, just for us to understand, and see what happens if we let that video game go. And then does that have anything to do with the reality? And we can do these kinds of things and try them and just then check whether they actually fit what we see in the field or they don't.
While we're talking about field work, I know sometimes archaeologists' work will take them all around the world to dig in the most unique places. Where have you been? What have you dug? What have you seen, Alfredo?
Okay, so in this case, I have not been in really exotic places because my main field of work happens in France and Spain, which is really cool, but it's not the most exotic places. And what I do, I do research on the last hunter-gatherers. That's the last people who were still hunting in Europe, and how the first people who started farming arrived to these places. So in this sense, I mean, I found lots of ancient pottery, ancient bodies, ancient arrowheads, ancient rock paintings, and all of these kinds of things that come together with this period.
And when you're finding these things, how much of it is filling in the gap of what we don't know, or do we have a good idea of what these hunter-gatherers were like, and it's just really confirming it for us?
Well, I was having actually a meeting before with some people here at the Institute, and we were talking about something similar to this, of what we don't know. And one thing I was saying is it's important that we scientists sometimes admit that we don't know, and there are things that we don't know. So we know a lot. We know a lot of what they did, a lot of how they behaved, a lot of what they ate, how they related to each other. But there are lots of things that we don't know. And these come out as we excavate new sites, because there's this metaphor, every site is like a book that is waiting for you to read it. As we have new books, we learn new things. And as we excavate new sites, we can learn more things that can change what we were thinking up until now. And that does happen in archaeology, something that happens. Someone finds this new site, and then everything we thought is like, okay, we were wrong. We need to change this because this new site just changed everything we knew until now. So that happens.
While we're thinking about what we don't know, Alfredo, we always finish our Battle of the Sciences in the same way. If I were to throw you forward years and years and years and years, when you're finishing off your career as an archaeologist, what's the one discovery that you really want to make? What's the one question that you want answered?
In terms of science, what I want to answer, so I want to know exactly how was this change from hunter-gatherers to farmers? How did the humans involved in this change, how did they embrace it? How did they treat it? Were they happy about it? Were they collaborate in this? Did they collaborate in this change? Did they have problems with this change? So this is one of the main things that I would like to know about. What exactly did happen at a human level? What were the relationships between these hunters and these farmers?
Over how long is that time scale, Alfredo? Was it one morning they woke up, these hunter-gatherers, and thought, you know, I don't want to go out and find my own food. I'd rather just dig it from the ground and cultivate it myself. Or was this over thousands of years?
Yeah, well, neither of those. It's very different across the world. So I'm just not making things complex. I'll just focus on Europe. And in Europe, the case it was you had some people living here who were hunter-gatherers, and then you had farmers who started expanding and migrating from the east. And then they arrived to different European areas, and slowly the people living in the hunter-gatherers living here started either adopting farming or being substituted by the incoming farmers. And this process varies, the length of the process, but it took, we're looking at several hundreds of years. That's the kind of scale we're looking at.
And that's what we're focusing on with archaeology. Alfredo Cortel Nicolau, thank you for joining us.
Thank you very much.
Thank you so much to Alfredo Cortel Nicolau for coming on the show, for telling us why archaeology, digging through the past, is the world's greatest science. We'll have another expert trying to prove why their field should come first next week on the show. Earlier on, we spoke to Tom-Joshi Cale from the University of Exeter, all about whether Earth might one day leave the Milky Way. So let's head back to space, shall we? With Harry and Terry from the Space Cadets. This is an episode from their series. They're trying to fulfill their brand new mission.
Welcome along to the astro adventures of the Space Cadets.
And sprinkle on the cheese and we're done.
Lovely. Top pizza, mate. We just need to cook it now.
What are you boys up to?
We've made a pizza zingy.
Yeah, we just need to cook it now. Any bright ideas?
Well, what's wrong with the oven?
Oh, we can't use that. We've got tonight's roast chicken cooking in there.
But then why do you need a pizza, Terry?
Pre-dinner snack. Harry likes his pre-dinner snacks.
Yeah, I need to have a pre-dinner snack, especially before chicken. It's something about poultry, you see, Zingy.
No, I don't really see. But I'm trying to understand you. Is that really ham with pineapple?
Ah, the Hawaiian pizza. One of man's greatest achievements.
Yes, quite.
Guys, I've got some seriously bad news.
What is it, Harry?
I think we've nearly run out of cheese.
Is that it? You have me worried.
It is a worry.
Well, no time for it now. Mission Control have just sent a message through. We're off to the moon.
Fantastic.
Yeah, and we can solve our cheese situation.
Oh, Harry, the moon is not actually made of cheese, you know. That's just an absurd myth.
Really? Oh.
The moon's surface is actually comprised of many different chemical compounds, mainly silica-based, which is found in sand, but none of them dairy-based, I'm afraid.
Oh, I'll put my crackers back then. Still, I can't wait to land on the moon. Isn't the Earth's moon the place where humans first landed in space?
Yes, in 1969, man first landed on the moon. American astronauts Neil Armstrong and Buzz Aldrin were the first men to walk on the moon.
One of man's greatest achievements. Space travel.
Yeah, it's okay. But let's not go mad and forget the sheer genius of the Hawaiian pizza.
Yes, Harry. But did you know the moon is the Earth's only natural satellite?
What's a natural satellite?
It's a body or object which orbits a larger body, usually a planet. The moon orbits the Earth every 28 days.
Why does the moon look different shapes at different times when I look at it from Earth?
Well, The moon reflects light from the sun, which is why it can appear so bright. But as it orbits around the Earth, different amounts of the sunlit side are visible. This creates the different shapes you can see: full moon, half moon, crescent moon, and so on.
So what's our mission, Zingy?
Mission Control would like us to investigate an old NASA landing site from when man first landed on the moon in 1969 and report back on what it's like today.
Cool! You excited too, RoboWolf?
Hold tight for landing, boys. We're nearly there.
Wow!
I've positioned the ship just a couple of miles from the first landing site of the Eagle craft from the Apollo 11 mission back in 1969. Take RoboWolf out in the investigation pod and bring back some photos of what the site's like today.
OK, Zingy, no problem.
And remember, keep your spacesuits on at all times. The moon has no atmosphere, so be careful.
The landing site should be just up here. You okay driving, Terry?
Fine, thank you.
It's just the ground's quite dusty and there's craters to watch out for.
I know, I can see them, mate. I'm not you.
Hey! Oh, wow! Terry, can you see that? It's the old landing site. Is that an American flag?
It's a bit battered, but yeah, it is. The stars and stripes, the American flag. Neil Armstrong and Buzz Aldrin must have left it here.
You getting photos of all this, RoboWolf? I'm getting out and having a look around.
Yeah. Hey, look at these footprints in the moon's surface. They've survived in the dust all these years.
One small step for man, one giant leap for... RoboWolf, come back here! We need you to take more photos of the site.
What have you found, boy? Harry, look at what RoboWolf's found. It's an old NASA moon buggy. It must have been left here.
Oh, wow. Does it still work?
Harry, it's not going to still work.
You were saying? Mate, there's two of us. We have an investigation pod and now a NASA moon buggy.
Dude, are you thinking what I'm thinking?
I know. The Hawaiian is definitely the most underrated pizza.
No, not that. No, I think we should have a little race.
Oh yeah, let's do that. Let's start at these footprints, go round the crater over there, and finish at the old American flag.
Sure. I want the NASA moon buggy. It looks speedy.
OK, I'll take the pod. Get lined up. RoboWolf, can you start the race, please?
OK, RoboWolf. Ready when you are.
Go!
I'm going to beat you, Harry.
Come on, then. Hey, watch out. We're on the edge of the crater here.
I'm going to win, Harry. This NASA moon buggy is super speedy.
No!
Ah!
Terry! Are you okay, man?
Yeah, I'm fine. Oops, the tyres burst. Probably shouldn't have driven it so fast.
Do you think this is what Zingy had in mind when she said investigate?
I don't know. Hope so. Come on, let's get back to the ship.
Welcome back, boys. How was it?
Oh, Zingy, it was amazing. The flag's still there and the footprints and everything.
Fantastic. NASA will be happy. Sending copies of RoboWolf's photographs to Mission Control now.
And RoboWolf even found an old moon buggy too.
Incredible. Well done.
Yeah, it looked like it was in pretty good nick too.
Yes, all spacecraft and vehicles are built from the highest quality materials. Well, except for my old ship. Spaceship cutbacks, that is. That moon buggy will probably stay in one piece for many more years. Harry, why do you have a moon buggy wheel under your jumper?
Oh, this? It's a souvenir? Join us next time for more Astro Adventures with the Space Cadets.
And that's it for this week's Fun Kids Science Weekly. Thank you so much for listening. If you would like to come along to see this podcast live on stage, find out more about where I'm playing near you all summer long, get to funkidslive.com/tour. If you have a question that you'd love answered on the show next week, make sure you leave it as a voice note on the free Fun Kids app or at funkidslive.com. We've got loads of brilliant podcasts that you can hear. Google, Apple, Spotify, wherever you get your shows. And Fun Kids, we are a children's radio station from the UK, listed all over the country on our app, on the website, and if you've got a smart speaker, wake up and ask it to play Fun Kids.